Today we're going to be doing an investigation using the properties of soil, and one of the properties of soil is the ability to retain water. Other properties of soil might be its texture, its color. That's how we can identify it and classify it. When we classify something, we put it into groups. So things that would be rocky, like this, we could classify as gravel, small pieces of rock. Soil that we use for planting, we could classify as potting soil. Okay, and then over here we have a more powdery substance, and it has a certain color to it, a reddish brown. We classify that as clay. Okay, so what we're going to be doing is we're going to be using the beakers, and I've already labeled them for you. One is called potting soil, the other one's gravel, and then we have clay. On top of those beakers, I've placed a filter. This is a coffee filter, okay? And we use this because it's a kind of paper that can let water through, but it's thick enough so that it can hold whatever material that we're putting through there. So it works as a filter so that we can drain. We're going to go ahead and use the 3 different types of soil. We're going to measure 50 milliliters of each. And what I'm going to do is I'm going to place carefully, because I don't want it to bust through the actual filter. That's 25.
Didn't you say 15?
And that's 50. We're going to take 50 milliliters. That's 25. And there's my 50. We have those filters are holding on with a rubber band. And the clay is very powdery.
Wow.
That's 25. And there's my 50. Okay, now what we're going to do, we have our beakers sitting there with a filter on top. We have our 3 different types of soil. This back here is called a graduated cylinder. They call this a graduated cylinder because at the bottom, it looks like it has a graduation cap at the bottom, okay? So, because of its shape, they call it a graduated cylinder. Now, we have already filled out some of our paperwork and we made predictions. Raise your hand and someone tell me what your prediction is according to what we're doing here. What prediction do you make? Which soil is going to retain the most water? Galilea.
The potting soil?
The potting soil is going to retain the most water. Why do you think the potting soil will retain more water?
Because it absorbs it.
Because it absorbs it? Okay, that's a very good word. Alex, which do you think is going to retain the most water?
The potting soil.
Why?
Because, well, like we put it in plants, right? So it could help the plant, so that's why it's called potting soil, so the water would go in there and stay there.
Okay, so you're using your background knowledge. We obviously use that for a reason, right? We use it for potting our plants, so it holds the water. That's a very good way to make a prediction. You're using background knowledge. Go ahead, Marcos.
I think if you put water, it will not, like, the dirt will not break, only the water will go through. Like, if you put water, it will not sink, like the dirt will go down.
So you think it's going to break through the filter?
I'm not saying that it will say, like, you want to break in.
Okay. Well, if we were to put the right amount, it could break the filter. But right now we put a certain amount for a reason, because that's going to hold. And we're looking to see which one's going to retain more. Now there's also something else that can happen. We can pour water and it can retain it, but then some of it might not be retained, and that we call runoff. It can no longer hold it, so it runs off, okay? And that's the water that's going to drain through the filter. All right, which one do you think will have the most runoff? Raise your hand. Cesar. The gravel. Why do you think the gravel will have the most runoff?
Because it's like rough and it has holes in it.
Okay, because there's a lot of cracks and holes and it can go through. Very good. Fatima?
I think the gravel, because the gravel has like space.
It has spaces where the water can creep through. Okay. All right. Let me have my 3 volunteers. They're going to pour 50 milliliters of water. I already put the water in the graduated cylinder. So they're going to pour, and they're going to pour it at the exact same time so that we can see which one is going to let most of the water run off and which one is going to retain the most. Okay, guys, you ready? I'm going to count to 3 and then you pour, okay? Be careful with the clay so that it doesn't splatter everywhere, and the same thing with the soil. Okay? Go ahead and grab your cylinders. Okay, 1, 2, 3. Go ahead and pour it all.
All of it?
Go ahead. Do it slowly, Fatima.
Oh, God.
Go ahead. Pour it all. Alright.
It's gonna be hard to clean up.
Yeah. Okay. So we're gonna go ahead and pause the video, and what I want you to do on Edmodo is I want you to comment on your predictions so that I can see who viewed the video, and then we will come back and see what the actual product was. Okay, we've waited approximately 10 minutes for the water to take its time and to drain if it was going to drain. And while we were waiting, we were talking about controls and variables. Can someone raise their hand and tell me, what does control mean? Marimar.
The same type, like the same amount or the same thing?
Okay, the same thing. It means it's what does not change. It's controlled. It stays the same throughout the experiment. What is an example of a control in this experiment? Orlando.
The amount of water.
The amount of water that we poured, we used 50 milliliters on all of them. Saida.
The amount of soil.
The amount of soil, we put the same amount of soil on each container. Leo. The filter. We used a filter on every single one. Give me another control. What else did we have? Mia. The cups. We use the same type of cups on each one so that we're able to visually see what's happening and it looks similar. That's controlled. Now we also talked about a variable. What does variable mean, John Anthony?
It means that it changes.
The variable is what changes in the experiment. What changed in this experiment? Marcos.
You can see like in a clay that is going through like little.
Okay, that's not what we were talking about. We're talking about the variable though. We are seeing changes happening, but the variable in this experiment is what? Nicole?
The different types of soil.
The different types of soil. That's our variable. The controlled is what we see the same. The cups, the amount of water, the amount of soil that we used on each one. And the variable is that we change the soil from one to the other. Okay? So now, it's been sitting there for a little while. We're going to see if our predictions were correct. So what I'm going to do is I'm going to, carefully so it doesn't tear,
It's carrying.
I'm going to try not to squeeze it so that I don't affect the results of the test. Don't want it to tear. And this one's the messy one. Watch out. All right. Okay, now can someone tell me, is the water in the jars the soil retained or the soil that it drained? Alex.
The soil that it drained.
It's the soil that, the water that drained, not the soil. The water that drained, okay? What we have in the cup is how much runoff we had. Alright, so what we're going to do is we're going to take this and we're going to pour it. And I don't want to spill any of it. Into the graduated cylinder, and that's my potting soil. There's my gravel. And there's my clay. Alright, now that we have the three measured, you can see the amount of water there. Let me see who can read this.
23.
23 milliliters.
15. 39.
39 milliliters.
7.
And 7 milliliters. Now here's a tricky question. Which soil retained the most water? Now think carefully before you answer. Which soil retained the most water? Efren.
The clay.
The clay, how do you know that?
Because retain means what it absorbs.
Okay, good. So the clay actually absorbed more because I have less drainage. It drained the least amount. So when we have a question, you need to know which one they're asking for. And sometimes we think that because this one has the most, we want to say that gravel retained, but we're not talking about how much water we have. We're talking about how much water did not get soaked up. Okay? Very good. Our experiment worked out really well. Which one was the one that least retained water? Least retained water. Cesar.
Gravel.
Gravel. So was your prediction correct?
Yes.
Yes, it was. Our prediction was correct because the gravel had the most gaps, and as you can see, the water's all the way up to here, and it allowed the water to run off. It let it run through. Okay?